And welcome TypeScript. What is TypeScript, you ask? Well, TypeScript is a superset of JavaScript, which is a massively popular language because it literally powers web programming. But you see, JavaScript has a problem. When JavaScript was initially introduced, it was actually very uncommon to write more than a couple dozen lines of code because JavaScript mainly powered small interactions on the website or micro interactions, and it wasn't actually meant to power anything other than that. So you know that writing any complex applications like a powerful backend or a complex front end on JavaScript can get very tedious very fast because you can get into various runtime errors and so many bugs can be introduced simply because you're using JavaScript. Now all of this is mainly because JavaScript doesn't have a strong type system. And that's where TypeScript was born. Now, the major difference between TypeScript and JavaScript, of course, is that TypeScript has a very strong type system. Of course. Let's see this in action. So take an instance where you have a const x equal to 10 or whatever. And we know that this is a number because it's very clear to us right now. But what if somewhere later into your code, or you've just passed this variable somewhere inside a function and you're not sure whether this is a number, because in JavaScript there is no actual way of knowing the type of the variable, right? Now, what do you expect to happen when you run inappropriate functions? Let's say a map, which is applicable on arrays, or a length function, which is again applicable on arrays. So what do you think will happen in that case? For example, let's consider that I have my length equal to x dot length. And what do you think will be logged when I try to run this function? Get undefined. And as you can see, I'm not even getting any error over here. My ID does not know whether this is right or not. It cannot help me anyway. And all of this is because of JavaScript. So if I simply convert this file into a TypeScript file, I'll get an error. That property length cannot exist on type 10. Now, it is a type 10 and not a number because it's a constant over here. But I can actually give this a number type by just doing this, and then yeah, I'll be able to see that yeah, this is a number type, and then I cannot actually have a length associated to it. Similarly, if I try to do any other function, like yeah, let's do map. I'll clearly get to know that map cannot exist on number. It can only exist on arrays, right? So for example, if I change this to an array now, of course, then I have to change the number type over here as well to a number array, and then my code will work fine. So at least we get static type checker when we're using TypeScript. That is one of the major advantages when you are using TypeScript. Now, of course, because TypeScript is smart, you don't need to actually provide the type. The type can be inferred very easily. So if I hover over X, then it knows that it's a number array and I don't need to specify the type. So that is another beautiful thing about TypeScript. It is pretty smart to infer types. But what about the case when you want to reuse some type? For example, let's say you have a object over here. If we hover over it, then because of TypeScript, we know the type is name, age, and is married. That's great. But how can we make sure that we can reuse this type? For example, if you want to pass it to a function, I don't want to repeat this everywhere, right? I don't want to repeat this type everywhere. I don't want to say it explicitly. I want to have some sort of way in which I can store the type somewhere and then pass it in different places where it's needed. So I can reuse it. So what do I do it in that? What do I do in that case? So in that case, you can use something known as type aliases. So it's pretty simple. It's like type person, and then you just give it the types that are required. So name has a string type, age has a number type, and is married as a boolean type, right? And over here, instead of passing the whole object, you can directly pass the person type alias, and the job's done. Now we can reuse this person type anywhere we want, and it will always refer to the name, age, and married with the appropriate types. That is a string, number, and boolean. Now, an other way to define types of objects is by using something known as interfaces. Let's just comment this out and define an interface called person, which, if you see, is very similar to how we define the type. In fact, it is so similar that we can use it interchangeably everywhere where we had defined type before. So the object will be of the interface person, and the print person will be taking in the print person of the interface person. So it's very interchangeable. So there are very few key differences between type aliases and interfaces, such that you can extend an interface very easily. Whereas in types, you'll have to go for something known as intersections if you're trying to extend a type. Now, an other difference is that you cannot add new fields to a type that has already been defined. So in the type, you cannot define type twice because that will be an error of duplicate identifier. Whereas in an interface, you can define it twice, and what it will do is that it will combine both the interfaces into a single interface. And now this window has both the title and the TS as its type. So that works perfectly. Now, another benefit of using interfaces is that it allows you to wrap all the properties that are required into a single place, very similar to type areas. And then you can pass this interface into wherever you want. So interfaces are very popularly used inside React.js when you're passing props and you want to define the types of the prop. Now next up is enums. Now enums are not a feature native to JavaScript. They're a feature native to TypeScript. Enums enable us to define a set of constants which we can use anywhere inside our code. So for example, you can define role, and then role can be of admin or user. And then we can use this as a constant anywhere inside our application. Similarly, enums are also very useful when we want to create a set of distinct cases. For example, directions. So an enum of directions would look something like this, where you have up, down, left, right, or north to east, south, west, similar to what I've written over here. Enums can also be used to show us intent, like a constant of intent. So for example, I can have an enum of response, which will be yes or no. So this is where enums are very powerful. They're used in creating a set of constants. Now enums stand for enumeration, and anytime you define it, it actually, the value of an enum inside, like this admin over here, role.admin equals to 0 and role.user equals to 1. So it's actually an enumeration of what's going on inside this object. And that's what gives it the value. Now during runtime, what happens is that enums are, since they're not native to JavaScript, they're compiled, they're transpiled into objects, and then they're used inside JavaScript. Just a fact that I thought you all should know. Now next up is generics. So generics provide variables to our types. So anytime you want to create your own data structure, for example, let's consider that you want to create a data structure called stack. Now stack will have items. Now what do you think the type of items should be? Should it be a string array? Should it be a number array, Boolean array, or some custom type? What should it be? Well, the problem with having a number type or a string type array in items is that it would restrict a stack to only contain number and string or number of string arrays. It cannot contain any other values. But we don't want that in our data structure, right? We want that to be decided when the user creates a new instance of the stack class. So how can we do that? So instead of providing the type as string array and making it equal to and initting it to an empty array, what we can do is that we can accept a generic type over here, and then we can use this generic type everywhere inside wherever it's required inside a function. Now what will happen is that our stack can contain anything that it wants. So right now this is a number stack. That means that the stack can contain values of numbers. We can have a string stack where the stack will contain string values. So that's the beauty of generics, right? You don't need to really restrict the data structure or any function to a specific type. You can keep it very generic, create your functions, and then you can accept the type whenever you're instantiating the class or running the function, and then use that type everywhere. So this way you get very good type safety, and you're not actually restricting the use case of your function or your data structure. Now, of course, in this video, I haven't covered everything. In fact, I've not covered most of the things. For example, I've not covered how to set up TypeScript inside an Express project. I've not talked about how TypeScript is used inside a React project. If you want videos on those separately, I can make videos on those separately. But in this video, I just want to give you a generic overview of TypeScript and how you can use it, why you should use it. And the best part is that you can start with your old projects, old JavaScript projects, and transform them into TypeScript projects one file at a time. Because any valid JavaScript code is also TypeScript code. So you don't need to compile or transfer or transform your whole code base into TypeScript. You can do it one file at a time. And I feel, in my opinion, this is the best way to learn about TypeScript. So yeah, that's been all in this video. See you next week.